In this video, we are going to find critical values of a function of two variables. And also we're going to verify that whatever we found is really a critical value. Okay, so I'm going to show you that because you guys are going to be required on any test to verify and make sure, and that's going to be actually worth some points if you know how to verify it, because that's important, right? Because if it's not a critical point, that obviously like everything else later in the problem is going to be incorrect. Okay, so in order to find the critical point, you have to find the gradient, which really just means finding the partial derivatives. And then the solution has to satisfy the equation each partial derivative set equals 0. Okay, and solve for x and y, which usually will be some sort of system of equations, two equations, two variables, to solve for x and y. All right, so the first thing is let's find the partial derivative with respect to x. So let's only highlight terms that have x in them, because everything else will drop out because we consider y as a number. So this will become 3x squared minus 2xy with respect to x. So think of 2 and y as both being a constant multiple. So it's like 2y multiplied by x. So how do we take the derivative of kx? Well, that's just k, like 5x is 5. So 2yx is just 2y. And then minus 54, right? Because that's the regular derivative. So that's your first derivative, right? The fx. So you're going to set that equals 0 and solve that for x in this and y in a second. But actually, this looks like pretty hard to solve. So let's see if maybe the other derivative is going to be easier. So now what we want is actually we do not want to highlight terms that have x. We now want to highlight terms that have y. So I'm going to unhighlight these, and I'm going to go ahead and highlight this guy now, right? Because these two terms have y. Okay, so the first one is now we're thinking partial derivative with respect to y. So x is a number. So this will be negative 2x, right? Because number y is the number. And then plus 8y, that'll just be 8. And of course, everything else is going to drop out. So from here, we can certainly solve this for x. So it's much easier to solve the second equation, right? So we are going to subtract 8 from both sides, and we are going to get negative 2x equals negative 8, and then dividing both sides by negative 2, that gives us x equals positive 4, right? So once you get that, now you have x equals positive 4. You are now going to plug that into the first equation, right? Because you have two equations, if x equals 0 and if y equals 0, right? So now using the first equation, we plug 4x, and we are going to solve this for y. Okay, so let's see if we can compute that. So this looks like it's 3 multiplied by 16, which I think is 48, minus 2y minus 54 equals 0. So 48 minus 54, I believe that would be negative 6. Now if we add 6 to both sides, that gives you negative 2y equals positive 6. And then dividing by negative 2, we get y equals negative 3. So that looks like it's a critical point. However, so for negative 3, we must verify it. So verify has a big question mark next to it because you guys are going to be required to do that. Okay, so what do we do? Let me actually copy the derivatives we have in here and just submit just to make sure I got that part correct. Okay, and then the next part is what do we mean by verify? So you're gonna have like a blank where you're gonna have to insert your verification. So the verification means that each point that is the critical point that you found must be substituted in both fx and fy, and you have to make sure you get 0. Okay, so the first one is we are substituting x equals 4 into the first equation and y equals negative 3. So it's going to be 3 times 4 squared minus 2 multiplied by negative 3 minus 54 equals 0. Yes or no? So let's see if we can just open the calculator and insert that. So you're going to have to show detailed work about that. This is not like a pretend computation. Okay, so this looks like that's 0. So this is 0. This is equal 0. Yes, that's satisfied. Okay. The second part is plugging in the critical point into the second equation. Well, that one only has x, and that one is very easy to check. You do not even have to use a calculator, so it's a yes. Now, what happens if your verification fails? So on the test, let's say you think this is a critical point, but you plugged it in and maybe it works for one equation, but it doesn't work for the other one, and it has to work for both for it to be critical point, okay? So what that means is you have to go back and you have to check your work. Okay, so something is wrong. When you were solving your equations, you made a mistake, because otherwise this should work. Okay.